Hello guys, welcome back to my YouTube channel. Today we are going to start a new series on the Kubernetes. So in this series, we are starting a strong with a deep dive into the Kubernetes architecture. So if you have already know what Kubernetes is, this video will help you truly understand how it works under the hood. So let's get into it. So now we will try to understand one by one what are all the main components of the Kubernetes with whether it respect to control plane or with respect to worker node. We will try to see in detail one by one. So to begin with, at the heart of Kubernetes lies the control plane. Consider it as a brain of your cluster. So it makes all the global decision about the cluster, whether it may be scheduling, scaling, and maintaining the desired state. So first we will discuss the components of a control plane. So the number one component what we are going to discuss is an API server, sometimes referred as Kube API server. So it's act like as a front door for Kubernetes. All CLI or REST request going through this, so it validates and persists objects in etcd. So etcd, so analogy, when we compare, think of it as an the cluster's traffic controller. So whatever traffic is going into the cluster is flowing through the cluster is managed by the API server. So coming to the next component, that is an etcd, distributed etc. Basically this is a key value database of the Kubernetes, so which stores desired and current cluster state. So it's highly available, consistent, and distributed. So, for example, it stores deployment replicas, config maps, secrets, all are stored in this etcd database. So the next component is controller manager. Basically, this runs background loops called controllers. So each controller watches objects and tries to bring the current state to the desired one. So for example, if a pod dies, so the replica set controller creates a new one. So the next component what we are going to discuss is a scheduler. So basically scheduler decides where each pod should run. So it checks resource availability, taints, tolerations, node affinity, etc. These are all the terms. If you are not aware of these terms, we are going to discuss in the upcoming videos of this series also. For now, you think of it as it will check the resource availability in the worker nodes, and if the resource is available in the particular worker node, or if it's not there in this that worker node, it will go to the other worker node and it will schedule your pod. Basically, it will decide where your pod should run. So for example, you can think of this like as chooses node with enough CPU and memory. Basically, if I give a signal to run a pod, it will choose a node where it can run a pod with enough CPU and memory. So this is with respect to the control plane. Now let's talk about the node components. So now on the worker side, this is where your actual application live. So talking about the kubelet, so basically the node agent that ensures containers are running as expected. So basically kubelet is an agent that is responsible to ensure that so the containers what and all created are running as expected. So basically it talks to the API server and container runtime. Basically it will, this agent will be talking to the your API server which is in control plane, and it will be talking to your container runtime. Basically that might be anything like docker or container d. So reports node and pod status. So this agent is responsible to report the status of the nodes and even the status of the pods. So the next component is kube-proxy. So this proxy component basically maintains network rules for pod communication and service exposure, handles internal load balancing. So this is responsible for the networking part. So basically the network rules for how the pod should communicate with each other and how the service will be exposed. So those things is managed by the kube-proxy. So the third one is container runtime. Actually runs the containers. So basically the container runtime is nothing but which is going to run the containers. It might be Docker, container D or CRIO. So when you deploy an app, your YAML goes through the API server, stored in the etcd controller, controller acts according to it, and the kubelet makes it real. Talking about networking, so sometimes networking in Kubernetes can seem magical, but it's just a set of clear principle. So every pod gets its own IP address. So pods can talk to each other directly, no need of NAT. So nodes use a CNI, that is container network interface, plugins like Calico, Flannel, or Cilium. So service objects provide stable DNS names and load balancing for pods. So by this, these pods can communicate to each other. So basically, this is all about the networking. So in details, we will talk about in the upcoming videos. So for now, as of now, as you can see, this is it. So that's a quick, a deep refresher on Kubernetes architecture. So in the next episode, we will set up a real multi-node cluster using kubeadm on AWS EC2, and you will see these components come to life. So if you found this video helpful, hit like and subscribe. We are just getting started. Thank you guys. Thank you for watching the video.